Hi, my name's Luke, and in this video we're going to talk about how vapor barriers work. It is one of the most commonly misunderstood elements of construction, and in this climate that I'm in, Manitoba, Canada, currently December, it's about -6 outside, which is a little warm for December, and Manitoba, Celsius by the way. In our climate, vapor barriers are extremely important. And as I was talking about in a previous video, with this area being like a heated space and this being unheated, cold space and insulation here, and how we talked about how the insulation would be getting wet because of the condensation that would be happening in here. The thing to do is to stop the air from getting to the insulation, to stop the vapor from getting to the insulation. Obviously, it's a vapor issue because it's the airborne water that gets in there and then condenses and causes the problem. So that's why we call it a vapor barrier. Technically, people have said that we should change the name to a vapor retarder because even plastic vapor barriers like these actually do let vapor through at a very, very slow rate, but most people who argue for that are kind of persnickety scientist people, so vapor barrier is still the word that we use because it's a barrier. Anyway. What we do if we want to make this insulation stay dry is we make it airtight on the inside, which is why with all these walls that have really been insulated by professionals, you can see that there is plastic over the whole thing. It is 6 mil polyethylene, I think, is what we use here. We love our 6 mil poly in Manitoba. We use it all over the place because of our risk of condensation that we have. Now, as you can see, they don't just put poly on the wall and staple it. They go, and they don't just go right to the floor and connect it all the way to the ceiling. They also caulk the crap out of this stuff. This caulking is called acoustical. It's a brand name. I think it's made by Mono. Acoustical, I'm just referencing that because of the fact that we use that term all the time when we talk about vapor barriers. Whoa, tripping. The acoustical is actually a type of synthetic rubber. So basically what we're doing is we're putting liquid rubber all over our walls and ceilings and sealing the plastic with that. Otherwise, we would have little gaps. You see, for example, every one of these here electrical boxes would have a big hole there. We put a plastic box that goes on behind the metal box, and that plastic box is then sealed to the plastic of the vapor barrier on the wall here. So we've got inner plastic box and then plastic vapor barrier. If I put my finger in here, I can feel all the way to the back. The plastic is covering the entire back, and the only holes in that plastic box are where the wires are running through. You can see actually, whoop, right in there, maybe you can kind of see that wire. That little wire there is got some caulking around it as well. If I put my finger on it, yeah, it might transfer. It's not quite that sticky anymore. Anyway, it's very sticky stuff if you ever touch it, and it gets everywhere. So that wire is going through the plastic box, and it has caulking around it as well. We have to make the house airtight with this stuff. We are basically building a house with a plastic bag on the inside. It's like putting yourself in a Ziploc bag. I'm not kidding. This is what we're doing. We do it on purpose. And so there is a ton of this acoustical sealing everything. I'm going to talk about why there are lines all over the place of it. That's because every one of these studs are layered together. This is a set of studs that are being used as a post to hold up the beam above that goes above here. And every one of these lines, because there's a risk of air just being able to flow through the gap in between the studs, if there's a little bit of space, they seal over top of those. It's basically not so much for the plastic to seal together, because there's no lapse in the plastic here. There's no electrical holes. This is actually I think it's actually more to do with stopping drafts from coming in. Because if there was a draft coming in, maybe it would end up upsetting our plastic here. I know for a fact that on the bottom here, where we've got acoustic seal all along the bottom of the floor, where it connects to the floor, that there is being used to stop drafts that can come in from underneath the wall, because the plastic vapor barrier can't go through the floor, so it has to stop at the floor, and then it actually continues below. I will show that at another time, because currently this basement is not finished, and we cannot show what we do with the vapor barrier below. And so we do a lot of stuff. We've got holes in our ceiling for our lights. You think about every single light in your ceiling as a hole that goes into the attic, and the boxes that are over those are really big. Same kind of box as what we were talking about around the electrical outlet that we were looking at there, the metal box. These plastic boxes go right over top of this thing, which I think is going to be a speaker. That one there is a pot light. Pot lights throw off a lot of heat, and so it's imperative that that thing is sealed up really well. And you can see we've got red tuck tape is what that stuff is called, that is trying to protect the seams that were probably made in the plastic there. There's a little bit of extra frost right above that spot. Now I almost wonder if it's a draft getting through the plastic there. Because what happens when you have a hole in your plastic is the vapor-laden air gets through that little hole and gets into your spaces like your attic or your walls. And if you go into an attic in minus 40 degrees Celsius weather, you can find out where all your holes in your attic are. Every little wire that was missed when they were caulking, if they missed any. Every light box where the plastic on that plastic box that goes over top, if the end ends up curling up and lets air out just a little bit, you will have a frost plume that comes right off of that hole. And that frost plume will have a lot of moisture in it, and then in the spring it'll melt. And you know, you get calls when you work in the service industry that I do, saying, hey, there's rain coming in my attic in the spring, or even in the winter when it's just a really warm day and it's melting. And we have to explain to them, no, that's not really rain. Technically the water is falling, so you can think of it that way maybe, but that is actually from the frost, and that frost came from inside your house, because your house was humid. The reason why we have heat recovery ventilators in all new homes, a heat recovery ventilator, it's an appliance that's hooked up to your furnace, and basically all it is it's an appliance that brings in cold air from the outside, and it heats that cold air up with air from the inside that is being sent out. It's kind of like the two air streams cross in the middle and they get mixed around. They don't mix with each other. The heat of the hot air gets mixed with the cold air, but the vapor content does not get mixed, and then the inside air is sent out, the warm air is brought in, and the cold air that's now been warmed up is brought in, and that cold air that came from outside that has been warmed up has a lot less moisture in it, because that cold air from outside could not carry moisture because it was so cold, and it's been warmed up without adding vapor to it. That's how HRVs work. We could make a huge video about how HRVs work to try to explain it further, but basically HRVs are required in airtight houses in cold climates, because otherwise you're going to have so much humidity building up in your house. Your ceiling and your attic, your walls, all those tiny little holes that could exist inside of your house are not going to be able to take that much humidity. The condensation on your windows will not be able to take that much humidity, because you'll have tons of ice buildup on there once it gets humid enough. And believe me, it will. Our houses are so airtight. Back in the day, houses, when they were drafty, would have so many drafts that there would be enough cold-warm air exchange just breathing naturally, as it were, through all the little holes throughout the house, that the house would get so dry, you get nosebleeds, people would be shocking each other all the time because of the static electricity that happens with dry air, and you would not need to have an HRV system. Nowadays, we don't have a chimney like a gigantic hole in our house that's bringing in dry air all the time and letting out the humid air. We don't have holes in our walls. We don't have holes in our ceilings. We've got draft stopping procedures happening everywhere. And so we need to have something like an HRV system to dry up that air. There are different wall systems that use different types of vapor barriers and put vapor barriers in different locations in the wall. The reason why it's all on the inside, the warm side, is very, very important with this system, because we don't want to put the plastic on the back side, because then all the condensation will just happen in the insulation anyway. So it's very important that this is on the inside, on the warm side of the insulation. But there are different wall systems that can actually put the vapor barrier inside the wall, like inside the insulation, partway through. One of the rules of thumb is to say you can go 1/3 in and then not have to put it on the inside. Why would we do that? Well, there's a few reasons. I'll get into them real quickly here. One of them is, let's say I want to put a painting on the wall here, and I put in a nail, go bump, 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 poke it right there, and see, oh, I don't have any backing to hold the nail. I'm going to put it over here instead. And now I've got this hole in the drywall and in the plastic vapor barrier, and now that little hole can let in a little bit of frost in the winter when it gets humid enough inside and cold enough outside. And so if we were to be able to design our walls with the vapor barrier a little bit further in, we could have all of our electrical and our plumbing and nail holes from our pictures and that kind of thing. That wouldn't be such a big deal. It would be a lot easier to deal with that kind of stuff. But that kind of system gets tricky, and we could talk about that in another video maybe. Go on buildingscience.com and look up some of their vapor barrier and wall designs that they talk about there. Very good source there. And I think that's pretty much all I want to say about vapor barriers. I'm going to make another video where I talk about different problems that can happen with vapor barriers and insulation. I've already started to get into those a little bit. We're going to talk about that some more, and then talk a little bit more about different designs and that kind of thing. But for now, I hope you learned something. Yeah, vapor barriers.